Welcome to the third lab of our Introduction to Excel unit. Recall that in Lab 2, we used the equation describing the relationship between two variables, x and y, where x is your domain and y is your range. And here we are going to use table of values to develop a graph. To graph or plot an equation, we use the given domain, or we generate reasonable domain values in order to use. Sometimes that is based on the physical application problem and what values are reasonable, or through trial and error if we're trying to show a particular feature of the graph. The domain is often represented by variable x, but in any case, it is the values that are used for the independent variable. We should ensure that our equation has been isolated for the dependent variable y, and then use Excel to compute the range. These first two steps are the same as we completed in Lab 2, but today we'll use both the domain and range to generate the plot and use Excel charts to generate a scatter plot with smooth lines and markers. So before we complete a practice problem, let's check out the following plot checklist that outlines all the expectations for when you create a plot in Excel. Keep this checklist handy for when you're working on your Excel labs, particularly your Excel assignment. So all plots produced should have appropriate chart titles. For that, you use chart elements in order to produce them. They should also have appropriately labeled axes with units expressed if there are applicable units in the problem. The equation given in the problem should be labeled on the plot itself, just like if you were graphing a function by hand. Use Microsoft Equation in order to produce the equation. Any purposeless legends are to be deleted. Ensure that there is proper spelling and capitalization of titles. And you are expected to insert a header into your work containing your name as well as the lab number. The footer on the page is reserved to answer any questions that are asked in the lab. So if there's an application problem and you're asked to answer a particular question, you should answer that question within the footer. This plot checklist will hold more meaning once we go through some problems and ensure that we hit all the targets of creating a plot. Let's look at graphing linear equations. Remember from our unit on linear equations that a linear equation is of the form y is equal to mx plus b. This linear equation can also be written in function notation where we say f of x is equal to mx plus b. When you plot the data points that are generated from a linear equation, they form a straight line. Let's complete the practice plot 1. So open an Excel workbook and save it as Lab 3 in your Math 145 folder, and rename Sheet 1 as Plot 1. We want to use Excel to produce a professional plot of the linear equation y is equal to 5x plus 4 using a domain of 20 to 80 with increments of 2. When preparing your plot, review the plot checklist to ensure you include all the relevant elements. First, we create a table of values as noted on this handout. If you need more instructions on how to create a table of values, please refer to the Lab 2 instructions. One thing I want to highlight about creating your table of values is that you should use cell referencing in order to determine the values of your dependent variable. So you can see here, instead of typing in the value of 20 for x, I reference the cell containing the value of x. And then I can use the fill handle to complete all the values for your dependent variable. Steps A, B, and C went through creating the domain and range of the dataset to come up with a table of values for the equation of the line, but Part D gets into graphing the data set. So we highlight the domain and the range of your data. It says do not include the label, just the data. And then from the insert menu, choose the scatter with smooth lines and markers from the chart options in Excel. So watch these steps carefully. You can start off in the initial value, so the first X value in your data set, and hold your mouse down and drag it to the right and down until you have all of your data selected. Another way you can do this, if you aren't comfortable using your mouse, or if you have a laptop with a keypad that you find difficult to use, you can press the Shift key and use the down and over arrows to select an area. Now we go to Insert and the Charts group here, and we want Scatter with smooth lines and markers. So you can see as we hover over top of the different chart types, it describes what the chart type will look like, and we are interested in the Scatter with smooth lines and markers. You can see that a working chart has appeared on my worksheet. So along with the data, which is on the spreadsheet, we can move this chart around, but we're going to work with this draft in order to finalize the chart specifics, such as the labels and titles and equations and so on. So if you're using Excel for other purposes, keep in mind that Excel's recommended charts function allows you to preview the chart before selecting it. So while your data is still selected, if you were contemplating using a different chart type, say for a different course, you can hover over top of the chart type and it will give you a preview of what your chart would look like. Before we complete the majority of the formatting on the chart, we will move the chart to a separate worksheet. To do so, you right-click on the plot and select Move Chart, then move it to its own sheet. See here, we can right-click, Move Chart, New Sheet. We could call this Plot 1 Chart. And you can see a new tab is created, so a new worksheet within our workbook. And we still have our data on a separate sheet, and these two elements are linked. It's really important to note that it depends on where you right-click on your chart as to what editing options you receive. So if we right-click on an axis, we'll have the option to format an axis. If we right-click on the chart area, you can move the entire chart or format the chart area. And same with our data, you can right-click adding a trend line or format the data series and viewing the data as well. So make sure that you play around with the functions in Excel as well as where to click and how to edit the graph as desired. Step E says to right-click on the top right-hand corner of the plot in order to engage chart elements. While on the chart, we right-click, and we can see that this plus sign has been added. We can press on it. We can add some axis titles, and we can see the chart title is already visible. And now we need to edit all of these titles. Make sure you add an appropriate chart title, although this step is more important for an application problem. If we only have a relationship describing X and Y variables, we will say Y versus X, which is your dependent variable versus your independent, and then add labeled axes for all the plots. Ensure that you use units as well as what the variable represents if it's an application problem, and the other formatting options will be available from this menu. You can explore them and decide on what you would like your plot to look like, but the basic requirements are axis titles, chart title, as well as an equation on the graph. Let's edit the titles. So So we have here, this is y versus x. Can edit the horizontal axis, which is your x variable, and we can also edit the vertical axis, which is y. Notice that if you prefer to show these x and y variables on your axis, like we have in class, you can move the titles to a relevant location. And you can also flip these titles. So if you say format axis, there's an option to rotate to horizontal. There is some creative license involved with creating a plot. Make sure that you've managed to include all the checklist items and that it is a very professional document that you've created. In part F, we make sure that we label our graph using a Microsoft equation. This must be done on your data worksheet, so it cannot be formulated on the plot itself. You'll notice if I'm on my plot and I go to Insert, Symbols, there is no equation option available. This option is only available when I'm on my data worksheet. So I can go Insert, Equation, and in this case we've actually already created the equation for the table of values, so I can copy and paste this equation. So you right click, say copy, or you can use Control C. And now while I'm on my chart area, so click on the chart area, you want to right click and say paste, and it will paste the equation up in the upper left hand corner, and you can drag it next to the graph. Final step here is to add a header from the insert menu, and then make sure that you complete a print preview and save your work and check your final work against the solutions on D2L. To insert a header, we say Insert, select the text group, and you can see the option of header footer appears here, and you want to insert a custom header. In the left section, we can type our name and the lab number. Say OK, and we can look at a print preview, and you can see that our header appears above our graph. In order to put a plot, if you were to put a header on your worksheet, it's the same process. So Insert, Text, Header Footer, and you can see here right now this worksheet doesn't have a header because headers in Excel must be placed on each page separately. So you don't have to necessarily include a header on each page, but if you did want to include one, you'd have to manually place it on each page within your worksheet. So here we could write our name and the lab number. After completing each question of this lab, take the time to compare your solution for that particular question to the solutions posted on D2L and contact your instructor if you have any questions. Next, we will graph two different plots that are both nonlinear equations. We will use the same method as outlined for linear equations in order to produce a plot for these functions. Let's look at practice plot 2. An equation of the form y is equal to ax squared plus bx plus c is called a quadratic equation. When you plot these points, you generate a parabola. So we want to create a new worksheet and rename the tab to Plot 2. Then use Excel to produce a professional plot of the quadratic equation y is equal to x squared plus 8x on the domain from -16 to 8 inclusive with increments of 0.5. Once you've created your table of values for this quadratic function, you highlight all the values go to Insert, select the scatter plot with smooth lines and markers, and then you can move this chart to its own page by right-clicking. You may need to go through these steps more slowly and pause the video as you go, making sure that you can complete all the steps on your own. Now we need to insert the relevant chart elements. This is chart titles, and we can include variable Y, variable X, making sure that if you are graphing an application problem with units that you include those variables there. And this is Y versus X. I'm going to move the axis titles onto the axes themselves. You can see we can move the X to the X-axis, and Y can be moved to the Y-axis. We can also rotate the text of our Y-axis label to be horizontal. And one more step, we want to add the chart title. So go back to your worksheet, select the equation, and if you haven't created the equation using Microsoft Equation, you'll need to create it at this point. Right-click on the chart area, paste the equation, and then drag it onto your graph. Make sure that if there's any questions about this graph that you answer them in a footer, and you can include a header or a footer by going to text in the insert group. We're going to do a custom header here, so this is lab number, and making sure that you include your name. And you can even view your graph by completing a print preview. For plot 3, we're going to plot a trig function, y is equal to sine x. The data points that we generate for this equation will produce a graph of a sinusoidal wave, and that applies for both sine and cosine functions. We will create a new worksheet within the same workbook and call it plot 3, then use Excel to produce a professional plot of the trig equation y is equal to -2 cos of 3x for x values, which is your domain from 0 to 6 points. The trig function that we must use for this is called cos, and cos is a function that's built in Excel. So if you were just calculating the value of cos, you would put equals cos. But in this case, because we have a different function to calculate, we do -2 multiplied by cos, and then inside the function we'll use cell referencing. So we'll do 3 times our cell reference. The trigonometric functions in Excel calculate the value of the sine, cos, and tan function using values in radians. The domain from 0 to 6.3 may seem somewhat arbitrary, but this is approximately 0 to 2 pi. Remember that 2 pi is approximately 6.28. So we're actually graphing this function from 0 to 360 degrees. If you were given a domain in degrees, you must convert it into radians before applying the equation in Excel, because sine, cos, and tan expect that your domain is in radians. And if you need a reminder of how to do so, make sure that you review the unit on angle unit conversions and recall that pi radians is equal to 180 degrees. So using our unit conversion factor method, we can convert a list of angles in degrees into angles in radians. Now creating a new worksheet. Calling it plot 3. We can insert our equation, so x as well as y is equal to -2 cos of 3x. Notice that these two equations simply serve as headers for my table of values, and they are not actual calculations. They're just for visual reasons and labeling purposes, so we can resize the rows and columns to fit the equations. We want a domain from 0 up to 6.3 using increments of 0.3. If you're having trouble with any of these skills in Excel, make sure you contact your instructor and get some help. So by meeting on WebEx, we're able to troubleshoot and figure out any issues that you're having in Excel. Okay, here I use cell referencing to reference value of x, which is a value in radians, and we have -2 times cos of 3 times x. Now we insert a chart, and we're able to finish off this chart by adding the titles, the equation, and the header, as well as moving it to its own sheet. So make sure you complete those steps now and verify your work against the solutions posted on D2L. And don't be shy, ask for help if you need any assistance with completing these labs. Once you complete this graph, it should appear similar to this one here, where we have an equation. The type of graph is scatter with smooth lines. We have a chart title, a header, and the equation shown on the graph. You can see my little axis titles here, X and Y. Take care, and we'll see you in the next lab.